Friends, you know that previous time I discussed with you all different related terms with the equations of motions, right? Number one, we have three equations of motion. Number one, that is equal to v is equal to u plus at, right? Simply we can get derivation of this equation by two method. Number one is what? Graphical method. Number two, integration and differentiation method. Okay, but I think solution by graphical method we have done in 9th class, but this time I will discuss only integration and differentiation method. Simply first of all we will find out we will get a derivation of this first equation of motion, that is v is equal to u plus at. First of all I am telling the meaning of all terms, right? We can say v is equal to final velocity, okay, and u is equal to what? Initial velocity. And you know a is what? Acceleration, and t is time. Clear? So simply for getting derivation of this equation we have to understand the concept of final velocity, initial velocity, acceleration and time. The final velocity we can say there when body will stop, yeah, we can say body will reach at the final position, so that can be the final velocity. And initial, when body will start from first point, so that can be the initial velocity. It can be 0, it can be 1, anything, any number. And acceleration, we know that change in velocity upon time. Okay, and time we can say there any time interval. Clear? So we will find out derivation of this equation by the method of integration differentiation method. And you know students, I explained in the GeoMap class there about the integration and the differentiation, so I clear everything related terms with the integration and the differentiation. But this time I will discuss with you all derivation of this equation, that is v is equal to u plus at. First of all, for getting derivation of this equation we need help of differentiation and integration. Integration will be definite only, not indefinite. Means we will give limits to it for getting the derivation of this equation. Okay, so just going to solve this equation. First of all we have take a concept of simply we have to take a concept of simply change in displacement. Okay or not? Okay, yes. One thing I'm telling, we know here velocity is equal to displacement upon time, right? But one thing, if we have 2 points, number one is A, second point is B, okay or not? Okay, if we can say this point is 5 and this point is what? 5.1. So how much change you are means see here, so simply we can say there 5.1 minus 5 we will get 0.1. so we can say here, so this will be the change in displacement. So velocity will be what? Velocity is equal to what? Change in displacement upon change in time. Change in displacement upon change in time. This d denote here displacement and this t will be the time period. And in different books they have taken different things like that delta s upon delta t. This s can be their change in displacement and delta t is equal to change in time. So simply apply there limit on this function. We will get what? Limit velocity is equal to limit delta t approaches to 0. This is delta. This delta showing here change. But simply we can see here when we will take this delta t approaches to 0, then we will get what? ds upon dt. This d by dt also showing here what? Change. both have a same meaning. Delta have the same meaning. This d by dt also have the same meaning. But simply when we will take the concept of delta t approaches to 0, this delta convert in the form of d by dt. This is the physics form, real physics form, by which we can solve anything else, because integration function can apply on the differentiation term, and differentiation can denote by d by dt only. Okay or not? Okay. Same thing you can take in the case of acceleration also. Acceleration, we know that a is equal to delta v, means change in velocity upon change in time. Simply you will apply limit concept also on it, that we will get what? Limit delta t approaches to 0, then we can say delta v upon delta t. This delta v upon delta t convert in the form of dv upon dt. So we can say here acceleration is equal to dv by dt. It's clear? So for finding derivation of these three equation, that is the equation of motions, so we will take help of only these two equation, these two relations, that v is equal to ds by dt, and second is equal to acceleration is equal to dv upon dt. So simply you have to keep revising, learning the things. So simply we can say that a is equal to d by dt and v is equal to ds by dt. Okay or not? Okay. So simple, we will derive a derivation of equations of motion by the help of this acceleration and velocity relation. Okay. For getting first equation of motion, we have v is equal to what? U plus at. V is equal to u plus at. So we can say for getting derivation of this equation, first of all we will take help of here that simple method, integration and differentiation. Okay or not? Okay. So for taking first one, we will take here first one, that is acceleration. We will take second relation. Acceleration is equal to change in velocity upon change in time. Change in velocity upon change in. What will you do? This is the differentiation form. This is the differentiation form. So we can say a is equal to dv by dt. So divide by 1, then take cross multiplication. We will get what? dv is equal to a dt. So this is the differentiation form. We can say this is equation number 1, or this is the differentiation form. Okay or not? Okay. So second thing, for solving this differentiation, we will integrate equation number 1. So simply integrate equation number 1. So when you will integrate, you will take what? A dt. Which integration you will do? You will take here for it definite integration we will take. So you can take this is the symbol of integration, this is the symbol of integration. So this is the velocity concept. So definite integral we will apply here. So we can say what? Initial to final velocity. So it will move from initial velocity to final velocity. Okay or not? Okay. Initial to final velocity, according to it, initial time period what was? What is? We can say that can be 0, and final temperature, that is T. Okay or not? Okay. Listen one thing. Then we can write this equation like it. This nothing is here, so we can write 1. It becomes dv. Same thing. This is 0 to t and a dt. I told those things which are present after d. So these can be the variable. So we can say this v also variable here, this t also variable here. So simply we can say we will differentiate, not differentiate, we will integrate this equation with respect to this velocity function here with respect to time function. So differentiate it, I told that simply the differentiation of 1, we will get what? V. And we can write this is starting from u, this is what? V. Same thing you can say here, a will come out, means a is constant, t is variable. So this a will come out because this is the constant number, nothing will happen with it. Okay, so we can write this is 1 dt. Okay or not? Okay. So we can say here v, that is u v is equal to what? A different integration of 1, that is what? T. We will integrate it from t to 0 to t value. Okay or not? Okay. Then I told you that we have two limit, upper limit, lower limit, upper limit, lower limit, upper limit, lower limit, upper limit, lower limit. We will put both limits into this given function, velocity function, variable function, and here same thing we will apply. We will put time period this variable function. Upper limit minus lower limit. You can change this v by this v and you can change this v by this u. Okay, we will get v minus u. Okay or not? Okay, and in this side we will get a, that is t minus 0. So we can say v minus u is equal to a t minus 0 t. Take this t in another side, we can say this become positive term, so we can say there a t, this can be the positive. So we get here equation v is equal to u plus at. This is the expression or derivation for first equation of motion. It means v is equal to u plus at. So we solved this equation by the help of integration and differentiation method. This is the result, final result. Tomorrow we will discuss here second equation of motion by this integration and differentiation method. This is the today's topic. Okay students.